Hello everyone, it's Benny, and in this video, we're going to be implementing fully generic materials. So no longer will we be constrained to having a texture, color, and specular values in the material. We can have any type of variable, data, whatever, that we want. And there's a lot of ways to do this. The way I'm going to do it is I'm going to do it with a hash map. It's just going to be a hash map that maps strings, which will be the names of the different variables and things that the material has, to whatever the type of thing it is. For example, textures. And it's that simple. So I'm going to call this texture hash map, sure. And believe it or not, yeah, it really is that simple. So in my main constructor here, rather than having initialize this, it's going to just initialize the hash map. And it's going to insert all these things into the hash map with some name. So my texture, but for now let's just initialize things. So that's going to equal a new hash map of string to texture. And I'm going to do the same thing for vector3f and float. If we need things that are, if we need more variables than that later, we can add them in the same way, but I'm going to do just these three with string to texture, and string to texture, string to vector3f, and string to float. Okay, we'll guess that float, but you know. And the reason I'm doing that is just because those are the types of variables we have right now. If we need more later, I'll add them. But this should get the idea across so that it makes more sense when we do it later. So this will be the vector hash map, well, vector3f hash map, and this will be the float hash map. And like all of them, I'm going to initialize them in the constructor. So vector3f hash map and float hash map are going to be equal to hash map of string to vector3f and string to float, just like with everything else. And while I'm at it, I'm going to go ahead and just change our constructors so that we just have one constructor. We have a new material, and that's it. So there. We're also going to need to change all our getters and such. So let's go ahead and do that. Whoops. Well, for now I'm just gonna, let's go ahead and delete it. We don't need it anymore. So all I'm going to do, for every one of these different hash maps, I'm going to have two things. One is going to be public void add of some type, so add texture, string name, and texture. Going to do exactly what you think it does. It's going to say texture hash map dot, put. Put with the name and the texture. There, that simple. Nothing to it. And I'm also going to have a public texture called getTexture, so I can get data out of the material. That's how it's going to work. I can have one function to add things to the material, and one function to get it out, which is just going to take in the name. And you could also have, say, you could also have like other methods for this, like remove texture or other things like that. But I personally, I don't think we should do that right now because we're not using them. Again, it's easy enough to get later, so, or, add later, so I'm not going to bother right now. And yeah, getTexture is just going to return that. And since these are going to be simple and generic, I'm going to put them on one line because I don't know, I feel like doing that today. That's purely a formatting thing. You can format them however you like. And yeah. So I've got my add and stuff. So I'm going to go ahead and create the other remaining add functions and the other remaining get functions. So the remaining add function is going to be add vector3f, if I can spell it right, and add float. And similarly, I'm going to have get functions for those. For get vector3f and get float. Yeah, there's no way to quite make that work. Oh well. And just like, they're going to do the same thing as all the others, except use the different hash maps for them. So vector3f is going to use vector3f, float's going to use float, etc., etc. And of course. And they're also going to return vector3f and float, respectively. So, well, yeah. Float value, and a... So yeah, this is really pretty simple. Now, actually using it is also going to be pretty easy, so you don't need to worry about that. And yeah, look at that. Our new material system, not only is it fully generic, it's also a lot simpler. So let's look at all the different build errors we've created, because we've created quite a few of them, I'm certain. Yeah. So let's go let's start in our test game. Right here. Because right now this is no longer a valid way to create a material. What I'm going to do is I'm going to start adding the different parameters to this material. So I'm going to add a texture. It's going to, well, I'll put in the name in a moment. It's going to have the new texture of test.png. And what my name is going to be, I'm going to be calling this texture the diffuse texture. Because the diffuse texture is the texture that's, well, what do you think of as a texture map? It's the one that gets affected by light and such. That's called the diffuse texture. So that's why I'm adding that. I'm also going to add a vector 3f. This one I'm going to call color, which is, actually, you know what? I don't need the color anymore. So I'm just going to skip that entirely. I'm going to add, so instead of doing that, I'm going to add a float. The float's going to be called Specular Intensity, and it's going to have the value of 1. And finally, I'm going to add one more float. This one's going to be called Specular, if I can spell right, Specular Power, and it's going to have the value of 8, because that's what I had before. And you can play around with these different values. Those of you who have been wondering why the directional light is looking a little extra special reflective on the plane, yeah, this is why. You can play around with these values and get something that you find looks better. I'm not doing that right now because it's not really a big focus. For me, at least. So anyways, now let's go into our different shader things and see what happens. Okay, basic shader. I don't need you anymore. Say goodbye to basic shader, folks. We aren't going to be needing him any longer. So yeah, it's gone. So that just leaves all our different forward rendering shaders. We need forward ambient, which right now is trying to get a texture. I'm going to get the diffuse texture for the ambient pass. And I'm going to do the same thing for all these different other passes. So this is going to get the diffuse texture, and I'm actually going to copy this just to reduce the chance of typo. So yeah, I'm going to go ahead and do that for all these. And finally, forward spot. Great. Actually, it looks like forward ambient's done. Let me just build to make sure of that. Okay, we've almost cut the error count in half, so we're doing something right. Now, get specular intensity. Well, this is where we're going to use our new generic methods. We're going to use .getFloat, and the float is going to be called specular intensity. And alright, that makes sense now. Sorry, got a little bit flustered. And the one that says specular power, similarly, is going to be called specular power. And that should actually fix the errors in the forward point. Yeah, exactly. So now I just have to do the same thing for all the remaining ones. It's going to need the specular intensity in forward spot and in the directional. And it's also it's going to need the specular power in the spotlight and the directional light. And it's honestly that simple. Rather than having explicitly defined, well, getters and setters for different parameters, we're just getting them based on a hash map, so it can be generic. We can have whatever different parameters we want in there. So now let's build. It should build, but it might not run if I made a typo in one of the names somewhere. But it does, and as you see, everything's working like before. Alright, great. There's one thing I want to do, however. What if, I don't want to specify some specular intensity and specular power. Let's just get rid of that. What happens? Well, not pretty things happen, that's what. Because now we're getting a null pointer. And that's really the only other trick to this. And so yeah, this is why I'm not going to, well, put the things like this. Because we're going to have to perform a check. We're going to say if texture hash map. Actually, wait. Does that... Wait, I'm sorry, I'm doing the wrong function. That makes sense now, never mind. I'm getting ahead of myself. The check is going to have to be in the getters, because this is where we can run into some trouble. What we want to do is we want to test if, well, if this is not equal to null. So, I'll just say texture result is going to equal this, and what I'm going to say is, if this is not equal to null, then I'm going to return the result. If it is null, I'm going to do something a little bit different, but I'll leave that, well, for a moment. I want to just go ahead and implement it for everything else right now. So rather than just returning it directly, I can have some vector 3f, call it result. It's going to equal that. Same thing with float, can have some float result. Actually, that's a good point. With float, it can't really be null, can it? Well, so I have to use the wrapper class. All right. It's not like that's a huge deal. It's just something I noticed. But yeah, just for everything, I'm just going to say, in fact, just this. If result is not equal to null, return result. And this is going to give me an error in every single one of these because, well, I don't have anything to return if it is null. For float, if it is null, I'm going to return 0. For vector 3f, if it's null, I'm going to return a new vector 3f 0, 0, 0. And for texture, if it's null, I'm actually going to return, because I don't have anything better to return right now, I'm just going to return the test texture. So, there. And this should at least not crash. It might look a little weird, but it should at least not crash. And yeah, you see our specular power, not really doing a whole lot at this point, but creating some interesting looking effects in our lights. But hey, it's not crashing. It is taking fully generic materials. And I'm going to go ahead and put this back. And make sure I haven't broken anything with this. And there, now it's working beautifully. But we have the benefit of fully generic materials. And that wraps up fully generic materials. But there's two more things actually that I want to do before I end the video. And that is, one, I want to get rid of the set rendering engine thing with the shader. So the shader is no longer going to keep a copy of the rendering engine. I'm going to implement the quote-unquote more permanent version of this. So none of that, and none of, no get and set rendering engine stuff. So yeah, what I'm going to do instead is I'm going to take it in as a parameter to update uniforms. It's going to take in some rendering engine. And it's going to be that simple. So before I break all my different forward shaders, I'm going to go ahead and change it to that and change get rendering engine to, well, the rendering engine parameter. In fact, yeah, I'll just copy all of them first and then change it. But yeah, the order doesn't particularly matter. This is just the order I'm doing it in. And well, that's really all there is to it. So now I'm just going to change everywhere that I say get rendering engine to the rendering engine parameter. Now the way I'm going to actually pass this parameter is going to be a little bit more interesting. But for now I just don't want to break all the different shaders, because that's just going to spam the output with error messages, and I don't want that. So there. Now all the errors should be localized to the rendering engine where the real issue is, because we're trying to set rendering engines and whatnot and not pass it. Yes, there. Ooh, or a mesh renderer. Well, okay, almost isolated to rendering engine. Yeah, I don't want to need to set the rendering engine anymore. No need for that. Rather, I'm going to pass it in as a parameter to object.render. It's going to take this. And, well, oh, that is my other error. Okay, never mind. So yeah, that's going to require changing the game object. So game object, rather than just taking in a shader, it's also going to take in a rendering engine. And this also makes a few other issues a little bit easier, such as the things where we need a rendering engine, like an add to rendering engine. You know, that stuff. But, oh, okay, yeah. So, this is one of the reasons why we're not going to need this later. I'm actually going to replace it with a different thing, but you could move it to render if you really wanted to. So it's going to take rendering, whoops. So rendering engine is going to be the other parameter to rendering the child, and also to rendering the component. Because I'm going to change my game component. I know, this is just snowballing ridiculously, but it's okay. Yeah, I'm going to change my game component to taking in a rendering engine as a parameter. This way, again, the whole reason for this is that I don't... Oh, rendering engine. Again, the whole reason for this is that I don't need to take in the other list of parameters. So, let's see. That seems to be okay. Actually, mesh renderer I think is the only one that's going to need it, so... Yeah, just going to need to pass in the rendering engine and the mesh renderer, and we should be good to go. With this change, at least. Still one more thing I want to do, but... aha! And pass in this when I render the ambient light. And that should actually be everything. So now, with that, it should not crash. Good. And now I can move on to the other change, which is in the game class. Whoops. Or I could close it, that works too, I suppose. But what I want to do is I want to get rid of this getter here. I don't want to have to get the root object. Instead, what I want to do is... Well, first of all, I'm going to go ahead and give it an inline initialization here, so that it will always be valid, but... And here I can just say root, dot input and whatnot. Or better yet, I can just keep this, but make it private. There. Because I don't want to have to be able to pass out the root object to everything. I want the game to manage that. So this is going to require how we're calling the rendering engine, because right now we're calling it with get root object. But, well, yeah, I can do that first. I was going to actually solve another issue that calls this first, but we can solve this first too. So rather than calling the rendering engine.render, I'm going to say private, not private, public void render, which is going to take in a rendering engine. So yeah, I'm just going to change the way this is done a little bit. It's going to be inverted. So, going to go ahead and import it. And, well, it's honestly that simple. So, yeah, I'm going to just render with the game with the rendering engine. And all this is going to do is it's going to call rendering engine.render with the root object. And the whole point of this sort of redirect shenanigan is, again, so that we don't have to give access to the root object, because later you can really start messing up the game by directly messing with the root object. So, yeah, we want the game to be in control of that. And that should also, well, that should only leave the final problem, which is we're adding things to the game by getting the root object. And here I'm just going to add new function, public void add object. And it's going to take in some game object, and this is going to call root, well, okay, get root object dot add child object. And also I probably want to change the rendering engine thing to get root object so that I don't, well, so that I'm guaranteed that it's not null. And yeah, so now all I have to do is replace it with this get root object.add child stuff with just add object. So, well, that's all there is to it. And with that really is everything. I'm going to build to make sure. It seems to have built. And, well, folks, there we go. That concludes the engine architecture segment. we've done just about everything we set out to do in this section. We've separated the engine from the game, so that the game is one thing, the engine is the other. They don't depend on each other to exist. We've also separated out the engine so that we have a core engine which manages actually running the game and distributing it to facilities that are more tailored to the task the game needs, like rendering. The rendering engine does that, it's not one monolithic blob. And we're going to do the same sort of thing with physics. And really, that's all there is to it. I realize this is one of the bigger segments, and I also realize wasn't one of the most interesting segments in the series. But hopefully this has given you an idea of how you can separate out, how you can architect your engine. Again, the approach I've used in this segment is not the be-all, end-all solution to, creating an architecture for your game engine. This is just one way of doing it that tends to be reasonably successful. You might want a different architecture, but hopefully, at the very least, this has given you an idea of how to do it. So thank you. I hope you enjoyed, I hope you learned, and in the next video, we are going to be starting the resource management section. So thank you, hope you enjoyed, and see you then.